Good morning and good afternoon, everyone. Thanks for joining us today for this new webinar. I'm Jean Giraud and I'm with the Several Lines team, and I'll be looking after you for the next hour or so. It's good to have you with us. If you have any questions during the next 60 minutes, feel free to ask them in the question section of your control panel, and we'll be happy to answer them, of course, towards the end of this webinar. If you have questions on any logistical questions, feel free to contact me directly. You can use the chat and also the question section if you have any issues with the system itself. And any topic questions, of course, feel free to ask them in the question section of your control panel. You can also contact me directly at jj@severalnines.com if you have any questions after today's session, and we'd be happy to go through them at this point. And just before we get started, I wanted to give you a quick introduction of Several Lines and ClusterControl, and who we are and what we do. We specialize in the deployment and management of open source databases, and this is centered around deployment, monitoring, management, and scaling of these systems. And we've combined all of our experience and knowledge into a product called ClusterControl, which you can use for these four main capabilities. The deployment and monitoring are free, and you then have management and scaling features as well, which are part of a commercial offering. This is a quick snapshot of some of the key features of ClusterControl automation and management, from provisioning through to monitoring, and a whole range of management features. We'll touch on some of them today because it's related to today's topic, and I'll get to that in a second. We support the following open source databases, the top three most popular ones between MySQL, MongoDB, and Postgres. And we are followed and used by over 12,000 users to date. You can see here some of our customers as well. And I hope this gives you a quick snapshot of who we are and what we do. But today is all about the deployment and management of the main load balancing technologies for MySQL and MariaDB, namely HAProxy, MaxScale, and ProxySQL, and all of this with ClusterControl. My colleague Christoph Schoncheck is going to present today in just a minute. And before we get started, I wanted to ask all of you a quick question to get things started. And this is to ask whether you're actually currently using a proxy or not today. So it'd be great to have your feedback here just to set the scene. Maybe you are just investigating and not currently using a proxy to do load balancing, or maybe you are. So just to get a good feel of who we have in the audience today. And great, I see that everyone's participated. Thanks very much. I'm just going to close this now and share the results. So it's a 50-50 split between some of you who, those of you who are using a proxy but are looking into new or additional information for maybe new options, and some of you, the other, who are investigating load balancing technologies at the moment for MySQL and MariaDB. So that's good to see. Thanks very much for your feedback here. And with that, I'd like to hand over to my colleague Christoph for today's presentation and demo.
Okay, thank you, JJ. So, as JJ said, we will be talking together today about deploying, managing a couple of proxies that we can deploy with the ClusterControl. My name is Krzysztof Książek, and I work at Several Lines as senior support engineer. So regarding those pool that we had, I hope that those of you who still not, they are not using the proxies or load balancers, you will find after this webinar why this could be a good idea for you to actually go and use one of those tools. Okay, so let's start with short agenda. So first of all, I'm going to talk about why do we want to use proxies. This is could be interesting for those who are still looking into this subject. Then I'll go through some overview of the proxies that can be deployed by the ClusterControl, namely HAProxy, MaxScale, and ProxySQL. And then I will give you a short demo of how proxies work, how proxies can be deployed and managed in the ClusterControl. So why proxies? Why do we may need them? So first of all, it is all about high availability. So obviously we want our systems to be available, to be highly available and fault tolerant. Therefore, we need something that will, that will detect the health of the nodes. And if needed, if the node is down, it will route the traffic away from the failed nodes into those nodes which are still available. I mean, you can do it with application, but it's easier, and I will follow on this topic later on. It's easier when you just have a tool like proxy and it just does its job, checking the health of the nodes, moving traffic if needed between, for example, available slaves in the master-slave topology. Of course, we're also talking about performance because high availability requires to have a number of hosts, nodes. So we're talking about, let's say, a couple of Galera nodes in the Galera cluster, or we're talking about master and several slaves in the master-slave replication setup. And obviously, high availability by just moving the traffic from one node to another, that's fine. But we would like to also utilize the remaining nodes for a read scale out. So proxies can help us here, right? They can take our reads and then they can distribute them across, let's say, multiple slaves in our master-slave topology. So some of the proxies, they can also implement connection multiplexing. And by that, I mean a situation in which, let's say that we have an application and it opens like 5,000 connections to the database. And obviously, it's not like 5,000 connections are, being utilized all of the time. So it's not like that 5,000 queries running on the server, because that would be pretty hard to handle for MySQL. But we're talking about situation where like some of them are running, but some of them are just idle. In that case, proxy which supports connection multiplexing might be able to squeeze this 5,000 connections into, let's say, 100. Because they are not being used all the time, and this is some sort of performance gain, because even if the connection is open, I mean, even it's idle, the open connection always uses some sort of resources on the database host. And another point that just kind of, which is pretty important, at least in my opinion, and this is somehow a follow-up to the first point that I had on the slide. We would like to hide complexity of the database tier from the application. So the database layer can be complex, can mutate, can change. We're talking about failovers, like adding new slaves, promoting new master, moving slaves within the topology, and it is possible to implement some, to handle this within the application. But this just adds some additional overhead. It is complex and it's not flexible enough, because if you have a code and you need to modify the code to adapt to some new situation, then you have to go through the whole process of writing the code, testing the code, deploying the code. While if you use a proxy as a point of entry into the database layer, you just point your application to one IP port or multiple IP ports, and that's about it. Yes, everything, the magic happens in the background. So the proxy will monitor the state of the backend nodes. It will understand replication topology. So if the master goes down, or if you promote a new master for some reason, then traffic will be routed accordingly. So the writes will start to hit the new master. If slave goes down, the connections will be failed over to another slave. So it just makes things so much easier for the application. It just needs to connect to one point, and that's about it. Also, we're talking about additional features which you can benefit from when you use proxies. First of all, if proxy works as a proxy, or proxies work as a single entry to your system, then all of the traffic goes through them. So you can collect performance data from the cluster, like you can all the queries passing through. So you can count how many queries you've been executing, how long did they take, some metrics which will give you some idea about the performance profile of your system and of your queries. Of course, if queries are passing through the proxy, some proxies can give you an ability to rewrite those queries. For example, what you could do is, let's say you have an query which you know that uses inefficient, like not correct index. You can rewrite it using index hints. You can do use force index or ignore index, straight join. You can just add those modifiers to the query, or you can rewrite query altogether. Like maybe there's it's possible to rewrite query into more efficient form. Then we can do it also with proxy. You can also some of the proxies gives the ability to route queries based on some sort of rules. Sometimes it's just very simple rules. Sometimes it's more complex. To the extent that sometimes it's just simple read-write split. Sometimes it's you can just match the query based on the regular expression and then send them somewhere, like maybe to either to master, to slave, or maybe to some particular host, like for some sort of analytical slave or ad hoc slave where developers can run some tests on the production dataset, but not affecting production at all. So this also can be like a benefit of using a proxy. Okay, so let's start with our review of the proxies that are supported by ClusterControl. Let's start with HAProxy. HAProxy basically it's an industry standard. It's very common. It is very common proxy to use. It's a TCP reverse proxy, and the main problem with HAProxy that alone out of the box it is not really MySQL aware. So it has no clue about MySQL. All it take care of is just to route packets. So it doesn't understand MySQL states, doesn't understand MySQL protocol. So it requires some additional scripts to be executed, to be used combined with HAProxy to actually, for example, make a difference between master and slaves. So as I said, the HAProxy does not understand MySQL protocol, and this implies that there is basically no option to perform read-write split on a single port, because for that the proxy would have to be able to differentiate slave selects from the rest of the queries. So it is possible to do read-write split on the HAProxy, but it requires two backends. So basically what you do is you define one backend for reads, one backend for writes, and each of them listens on different port. So basically your application has to be able to split reads from writes, and then direct reads to one port, direct writes to another port. This could be a blocker if your application can't do that. There are some workarounds, like for example, if you use PHP or Java, there are connectors, like the drivers, I would say database drivers, like MySQL ND, or for Java, that would be connector J, which can be configured to implement read-write split and then connect to two different ports on of the HAProxy. Actually, my colleague Ashraf Sharif, he had a blog post describing how this can be done. So if you're interested, you can look there, browse our website and in blog section. But well, if you don't have this ability, then well, you need to modify your application to implement this kind of thread split. As I said, on its own, HAProxy doesn't understand MySQL state. It can only check whether port 3306 is open or not, or if there's authentication string that's showing up when you connect to this port. So to make it more easy to use with MySQL, you have to use external scripts. Originally, I believe it was a cluster check from Percona. But there are a couple of different forks and modifications. Among others, something the script that ClusterControl deploys when you deploy HAProxy through it. Those scripts work on a similar way. So basically, you have external script located on MySQL or Galera nodes. And when executed, checks whether the node should be available or not, depending on some conditions. And then the script is configured as an XIND service, and HAProxy performs a HTTP check on this XIND port. We have a tutorial on how this can be configured. The link will be at the last slide, so if you're interested, you can check it how it can be done. And here you can see an example of read-write split configuration in HAProxy. So here at the top we have a read backend 3307. As you can see, we have three servers configured on this backend. And 3308 works as a writer backend. One server is configured to be available, two servers are configured to become a backup. And please know that this option, all backups, is commented. So right now, when this first server goes down, one of those hosts will become available. If this option would be on, then both of them would show up, which is not really something we want to do in terms of especially master-slave replication. And here you can see an example of how the statistic page in the ClusterControl will look like, statistic page of the HAProxy. So some information about the queues, information about the amount of connections, sessions opened, state of the backends, and so on and so forth. MaxScale is another example of the proxy which can be deployed by the ClusterControl. Yeah, I mean, it's created by MariaDB Corporation, even though originally it was, I believe, SkySQL. Currently in version 2.0, with 2.1 branch in beta as of now. ClusterControl deploys branch 1.4, and I will talk a little bit later why this is like that. So basically, it was when it came in 2015. This proxy, well, it was something great. I mean, it brought the ability to understand MySQL protocol and understand MySQL queries. So it made possible to implement read-write split just like you connect to IP port, and then the proxy figured out what should be sent where. It tracks health of bucket nodes automatically, so no need for more complex, maybe for additional scripts, external scripts to do that. It understands MySQL and Galera states, so master, slave, synced donor, primary, non-primary. So this all is covered internally by MaxScale. It supports SSO, supports on both client and server side. Support for replication, Galera, and MySQL cluster. It implements a simple query routing through statement hinting. So basically, you can, in a comment, you can define a hint for a query where to route it. Like you can say that this query should be routed to master only because it has to read the actual data, up-to-date data, and the safest way would be just to send it to master. Or you can define that the query can be sent to slaves, but only when slave is not lacking less than, let's say, 5 seconds. MaxScale can be integrated with Nagios. It also supports query mirroring, which is actually a pretty nice tool feature, because then makes very easy to very handy, I would say, when it comes to upgrade testing, for example. In 2.1, MaxScale implements query cache, so you can cache some of the queries. Also, a result set masking, which, for example, can be configured in a way that when some user connects to the proxy, it just gets the obfuscated data. Let's say there's a production data, but the result set is obfuscated. Let's say, for example, credit card numbers or some sort of personal private information is not available. Result set limiting works in a way that you can, like, if you are not sure how many rows the query will return, you can, for example, set a limit that the query will be killed if it returned more than, let's say, 1,000 rows, because you're not sure if it will return, let's say, 10 rows or 10 million. So you want to stay on the safe side. And also consistent critical reads. This feature is some kind of like enhancement over this hinting routing. So basically, it's designed to solve this read after write problem, in where you do a write to master, and then you immediately read from a slave, and the slave is still not having this data because it didn't get it from the master yet. So basically, you can define the time that after. So for example, after you execute some sort of write, for a given time, all of the queries will be sent to the master only, to avoid this read after write problem. MaxScale uses kind of pluggable architecture, and it uses modules called routers to perform different tasks. For example, there is read-write split router, which obviously performs read-write split. There's also read-con router, which implements round-robin access. The difference between those two is basically that read-write split router, it requires to get into the query, parse it, and then make decisions. Read-con route, it just works more or less like HAProxy, so just routes packets in a round-robin fashion. There is also a router which serves as a firewall, so you can filter queries based on the regular expression, which comes really handy when one particular not efficient query is killing your system. And it's better to block this particular query than go down in flames and have a downtime where if your database servers are not able to handle the load. Schema router helps you to implement schema-based sharding with MaxScale. Binlog router, it's a pretty common use case. So basically, MaxScale can act as a binlog server. This is actually quite useful if you're having very flat, I would say, replication topology. So let's say you have master and like 20 slaves, or like larger number of slaves. So all of those slaves have to, pull the binary logs from the master. And if there are many of slaves, it just adds overhead. So instead of pulling, the binary logs from the master, you can set up a binary log router, which will pull the data from master, and then all of the slaves will pull the binary logs from this binlog server. Some design decisions were made for MaxScale when it comes to how it handles traffic. So first of all, read queries are routed to master if executed within the transaction. So basically, when you open a transaction, like begin, start transaction, then all of the traffic will be within this transaction will be sent to master. And when you think of it, it makes sense because when you open a transaction, like you start run, you write start transaction, type push enter, and then the proxy has no way to know what kind of queries will be executed. To make sure the transaction is actually transaction, it has to be persistent. I mean, it has to stick to one particular host. And if you start to, like, say, from select, but then you start to do some writes, well, this could be a problem. Therefore, the only safe way is just to put everything on master. Same story is with stored procedures, user-defined functions, prepare statements. So this kind of limit the scalability, but make things safer regarding to transactions. Session variables, on the other hand, and settings like let's say, I don't know, character set, are sent to all hosts. So basically, MaxScale open connections to, for example, all slaves, and one connection is configured with there's always one connection configured the way that you configured your own connection. So in case you had the slave that you're connected to dies, MaxScale can reconnect you to some other host, but it will use the same type of settings that you had previously. And unfortunately, MaxScale does not provide connection multiplexing. So MaxScale, again, unfortunately, it lacks lack of real-time traffic statistics. So basically, there is no way to know to see what kind of traffic passes through MaxScale. This has been improved a little bit in 2.1 branch, but in 1.4 deployed by the ClusterControl, that's how it works. No remote admin interface in 2.0. It is available in 1.4. It's been removed due to some security reasons in 2.0. I would say the major problem in both 2.0 and 1.4 is that most of configuration settings require a restart. So let's say you want to add a new server, you have to restart MaxScale. This has been improved in 2.1, but again, well, it's first of all it's in beta, and second of all we don't deploy it. So there's just it's just this hinting when it comes to routing. So just hints, no more complex ways of routing the queries. No regular expression-based routing. And also the problem with scalability. So basically, if you're running with high concurrency, well, not even that high, as I'll show you in a moment. There are some problems with latency of the queries. Also, I mean, this has been actually fixed in 2.1, but there's also a progression when it comes to when you configure MaxScale to use more than 8 internal threads. Again, it will basically reduce the performance. The main problem that we have, I mean, the way that the reason that we deploy 1.4 version of MaxScale is that starting from 2.0, it is not non-GPL licensed. So basically, it uses a business source license, which allows you up to 2 nodes behind MaxScale free. But if you want to use more than 2 servers behind MaxScale, then you have to pay for that. So for example, if you have 3 nodes Galera cluster, you have to pay for MaxScale if you want to use it like that. So there is a GPL fork of 1.3 branch called Airbnb MaxScale. It is kind of focused on the binlog server functionality, which Airbnb uses heavily. So if you're not willing to use non-GPL MaxScale, then you can either use 1.4 or use this updated 1.3 branch by Airbnb. And this is more or less what I wanted to talk about, what I mentioned when I was talking about this latency problems. Let's take a look at this example. We have 16 concurrent connections to MaxScale and to backends. 95th% looks fine, 0.45 milliseconds. But the maximum latency was 400 milliseconds. 200 concurrent connections. 95th% looks fine, 2.35 milliseconds. Maximum latency was 5.5 seconds. 320 connections. Again, 95th% looks fine, 3.68 milliseconds. Maximum latency was more than 7 seconds. So basically, for some reason, some threads, some queries are stuck for even seconds, while others finish within milliseconds. So this is pretty bad, if you ask me, because it just prevents you from delivering the stable performance to your application. This has been improved in 2.1, but well, it's still not even stable, and we don't deploy it, unfortunately. So this is a screenshot where you can see how the management interface for MaxScale look like in ClusterControl. So basically, it's just a drop-down menu with some console commands that can be executed via MaxScale command line. And we should see more of that when I'll go to I'll start the demo. Finally, ProxySQL. So it was created also in 2015. It was a good year for proxies. By René Canal, currently in version 1.3.6, with 1.4 branch announced as beta. It was designed to handle complex topologies. And by complex topologies, I mean really complex, like, tens of shards, hundreds of database servers. That's so basically, quote unquote, web scale type of deployments. It can be configured to implement read-write split, supports multiple host groups. By host groups, I mean, or ProxySQL means a set of hosts which serve the same purpose. So for example, master can be one host group, slaves can be another host group, but some of the slaves can be also part of separate host groups. Like you can have maybe an analytical slave, or maybe you have a backup slave or ad hoc slave. So all of them can be members of different host groups. And then you can route queries to those host groups, basically. It tracks health of backends on per query basis, and it features advanced routing options for the traffic. And I will talk about it slightly later. So first of all, ProxySQL command line uses SQL to manage, which is, for me as a DBA, that's just very handy. It's also nicely scriptable, I would say. It is kind of like MySQL. I mean, it tries to be MySQL-ish as possible. Like for example, we can set variables using MySQL syntax, set some variable equal to some value. If you're not into command line, then of course ClusterControl UI will make it easy for you to make changes. What is also important is that for ProxySQL, virtually every setting can be changed dynamically. So there's no need to restart ProxySQL. Well, maybe you would need to restart it to change the number of internal threads or something like that. But all of the stuff that you want to do on a daily basis, like modifying query rules, adding host groups, adding servers, adding users, making some changes in configuration, all of this can be applied on runtime without the downtime required, needed when you had to restart the proxy. So as I said, it implements query rule mechanism. So you can match queries using different ways, different methods, like regular expression, hash of the query, user, schema, IP, address, port, different methods just to identify the particular query or a subset of queries. And then you can route those queries to different host groups based on this condition. So for example, let's say that you can route, then you can identify the user which is used by a developer, and then you can send those queries to a host group where developer is, or some sort of ad hoc slave is located, on which developer can run some queries without affecting the whole cluster. You can also use those rules to identify queries and to rewrite them. So you can match the query using regular expression and then some rewrite pattern, and you can modify it. Again, as I said, like it could be either index hints or complete rewrite of the query. You can implement query mirroring, so you can configure a query to be sent to different host groups, for example. You can cache a query, so there is eviction is based on the TTL, and there's also a memory limit to keep things under control. And of course, all of this can be done from the ClusterControl's user interface, as I will show you during the demo. ProxySQL supports connection multiplexing. So as I said, it minimizes the number of connections to backend. Supports MySQL replication and graph replication. Graph replication is supported in 1.4 branch natively. Galera cluster is not supported natively, but there are external scripts which are bundled with ProxySQL and which we configure for you when you deploy ProxySQL from the ClusterControl to make changes in ProxySQL configuration depending on how Galera works, what are the state of the nodes, and so on and so forth. So ProxySQL has a kind of non-standard approach to backend health monitoring. What I mean by that is, well, typically you will see that that some ping is being made. So there's just some sort of connection checks whether the backend is available or not. If yes, then query is being executed. ProxySQL, I mean, this is a problem because between this ping and the query, there's some time passes, and during this time, the backend may become unavailable. ProxySQL does it in I would say, the only sane way you can do. It basically sends the query. If query can be executed, then the backend is healthy. If query cannot be executed, the backend is down, and then it will try to find another host in the same host group and send the query to this particular host. So ProxySQL has a monitor module which is designed to handle cases in which there's basically a network problem and ProxySQL sends a query, but there is no kind of reply, because then it would have to wait until TCP timeouts kick in. So this monitor module just checks the state, and if the host is down, it will just mark it as down. And of course, ProxySQL gives you the ability to check the detailed statistics about the traffic that is passing through the ProxySQL. And we present this those statistics, this data in UI. And basically, here is how you can see. So we have information about some queries. We can create a rule based on the query. We have some information about the query execution, total of the how many queries were executed, total execution time, and so on and so forth. And I'll show you more about during the demo. So there is no client-side SSL support in ProxySQL so far. It is in the roadmap, but it's not there yet. In general, the transaction handling in ProxySQL is tricky because you have to make sure that you do it right to set all of the settings and query rules. And even though as of now, I mean, as of 1.3 branch, it is not possible to create a safe read-write split configuration when you're using implicit transactions. So when you or let's say your connector use the set auto commit equal to 0 and then issues queries, technically this opens a transaction. Thing is that as of now there's no way to make it transactional, because you will end up actually writing to master and, for example, reading from other host, which obviously is not a transaction at all. Therefore, for this kind of setups, and I will show you later, we cannot implement read-write split. For any other setups, we try to make the query rules in a way that this will be safe for you to actually see the transactions being really transactions and not just like writing to one host, reading from another. Likewise with session variables. It's also tricky to support because you have to make sure that everything is routed to a single writable host group. Again, this is done by the ClusterControl automatically for you. There's no direct Nagios integration and no internal support for Galera. I mean, the external scripts work, so it's not that big deal, but obviously it would be nice to have internal support for that. And if you're into fancy logging options like JSON or pushing logs to Kafka or whatnot, it's just simple plain text file so far, nothing fancy. So you need to go around this somewhere. And that's basically again another screen from the UI showing query rules implemented for the read-write split. And here we can see also some graphs, some statistics about the host groups. I'm going to show it to you in a demo in a moment, but before that, I'll hand over to JJ for the second poll.
Yeah, thanks for it, Christoph. Thanks for this. And so, before we get into the demo, we want to ask all of you another question. And this is directly related to what we just looked at. The three kind of main proxies for MySQL and MariaDB, and it's to ask you which one of those you're currently using or evaluating yourselves, or maybe looking into getting to know more, whether it's ProxySQL, MaxScale, HAProxy. There's also MySQL router, and maybe some other type of load balancing that you're using in your day-to-day work. So just to get your feedback here, it'd be great. Thanks very much for your participation. And just to remind you also that you can ask us questions, of course, at any moment by using the question section of your control panel, and we'll take a couple of minutes at the end of the webinar to answer those questions, of course. But for now, thanks for participating here in this poll. I'll let this run for another couple of seconds. Thanks very much. I'm going to close this now and share the results. Okay, so this is interesting. We had the same session earlier today already in an earlier time for Europe. And it was kind of the opposite. So we had a lot more HAProxy users earlier today than ProxySQL. So it's the exact reverse right now on this session. That's interesting to see. ProxySQL is still quite new, so it's nice to see it having such a wide usage already. And HAProxy is, I mean, that's been around for quite some time. It's still very popular. For those of you who said other, it'd be interesting to know what it is that you're using, of course. So if you want to give us the feedback, you can do it also in the question section of your control panel. Any comments on this, Christoph, before I hand back over to you?
Yeah, I think this is, well, similar like what we saw in the morning. This is quite expected because, first of all, ProxySQL is gaining a lot of traction recently, and HAProxy is obviously well known and well tested solution. While with the MaxScale, the problem is that, well, this licensing, it really becomes an issue. So yeah, and again, like the MySQL router, on the other hand, it's a very simple tool as of now. I'm sure it will gain a lot of traction when DB cluster will become more and more popular. But for now, it's just a very simple product.
Okay, great. So thanks everyone for your participation, and back to you, Christoph.
Okay, thank you, JJ. So let's go on with our demo. So as you can see, I have a master slave cluster with several proxies deployed. First of all, I would like to show you how you can deploy the proxies in a ClusterControl. You can either go to Manage Load Balancer, or you can from the drop-down pick out Load Balancer option. And then you will see different options here. For HAProxy, we can create a new HAProxy or add existing. We can obviously either pick one of the hosts or type the address of our own. We can define the ports for read and for read write and for read only. If we, by default, this is replication cluster, so by default ClusterControl is configured to install HAProxy in read-write split mode. So, but of course, you can disable it if for some reason you want to just use it, for example, to send traffic to slaves only. You can either install from package manager, or if you're not using or if your repository or distribution is not having the latest version, then you can build it from source. This actually is pretty important for read-write split because it requires quite recent HAProxy version. And then you can, define some other settings like port for the statistic page or timeouts, a number of connections, so on and so forth. And of course, you can define which host should be implemented. Added into the cluster, to the load balancer and their role. For MaxScale, it is quite similar. So you define, again, pick the IP or define the IP of your own. Command line admin username and password. MySQL username would be used for MaxScale to connect to MySQL. Threads, ports, and again, you need to pick which hosts from the cluster should be included in the MaxScale. ProxySQL, again, pretty similar. It's slightly different form, but the similar functionality. You just need to pick host where you want to deploy the ProxySQL, or again, type your own IP address. listening port can be changed. You need to define the command user for the command line, and you need to define a user that will be used by the ProxySQL monitoring module to connect to MySQL and, for example, check the state of the read-only variable, or maybe also, for example, the state of the replication lag. Later on, we need to create a database user on the ProxySQL, because and this is kind of similar how it works with MaxScale. So when you authenticate against the proxy, when you connect to the proxy, you authenticate against the proxy. So the proxy has to know the details about the user and passwords on the MySQL server. So basically, you can either create a new DB user, which will basically create this user on both ProxySQL and the database. So we can pick some grounds, we can type some password, and then define to which schema those grounds are applied to. If you have existing users on your MySQL server, you can add them here, and then basically let's say that this user will be created only on the ProxySQL side. And later on, you have again option to pick which host to include, the replication lag, the maximum replication lag, which can be, if the threshold is crossed, then this particular host will be marked as unavailable. Maximum connection per host and the weight, so you can set different weights to this host. And here is this question that you need to answer, which I kind of described earlier. So you have to answer whether you are using implicit transactions or not. So if yes, if you rely on set auto commit equal to 0 and then create a query to open transaction, we will just configure the query rules, so all of the traffic will be sent to master, and from there you can just pick create query rules to move particular selects to the slave if you want, but it's just safer to send everything to the master. If no, so if you use begin or start transaction to create transaction, then we will deploy basically query rules for every dry split. So let's take a look at the HAProxy. So as you can see, we have this statistic page about the number of connections, the queue size, number of connections right now, the data in out for the writer host group. As you can see, only one is up, our master, and for reader host group. Not much else you can do here. You can also, for example, mark hosts as disabled in the HAProxy. So basically, what will happen then, if you want to make some sort of maintenance on a particular host, you can take it out of rotation through this. For MaxScale, as I said, this is basically like entry to connection to the command line interface. So you can execute a command like you would execute it on the command line, and then you get some output. You can, for example, there is a drop-down menu, so you can pick different commands that are here. There's auto completion, so you just show servers, for example. So we have information about servers, right, shown here right now. So basically anything you can do from the command line, you can do through the ClusterControl, through this UI. So you can check some state of the host. You can do some operations like add user or remove user. You can restart service. So some of the things, well, that can be done through the command line. And finally, ProxySQL. So as you can see, first of all, we have some statistics about traffic, about the host groups. So we can see that we have 3 nodes in a reader host group. We can check some additional data. We can see that the queries are being executed, data is being sent and received. We can check latency and some metrics, some graphs that like memory utilization, query processor utilization, questions, slow queries. And this all comes from the ProxySQL. Query rules. So here you will see query rules configured to implement read-write split in ProxySQL. We can edit a rule, so you can add some data here and there. You can change the host group. We can set some timeouts and whatnot. We can of course create a new rule also for that. So same, you can create same form, just nothing is filled, so we need to fill it from scratch. Servers likewise, so we can add a server to the host group by filling some data. We can edit or remove the server from the host group again by making some changes and just remove it. For users, we have likewise, we have a list of users, so we can add a new user, which will open the similar type of form that we used when we deployed the ProxySQL. And variables, which will basically contain all of the variables that ProxySQL uses. We can scroll, we can search it. For example, all timeouts. We can make some changes here. Finally, top queries. So first of all, this is basically a list of I mean, if you worked with PT query digest, this is kind of similar method here. So this is list of query types, I would say. So as you can see, this is just select C from SB test 19 where ID equal to something, and we have information about how many queries of this type were executed, the summary execution time, minimum time, maximum time, some performance metrics. We can, for example, let's say we want to get the most frequent queries. And then what we can do is, for example, we can create a query rule from it. So some of the data is already pasted here, so we know that it will apply to this particular query type. And then we can, for example, cache this query by setting some sort of TTL, or we can set a timeout. So this query can be executed just for some period of time, and if it takes longer, then it will be killed. We can redirect it to one host group or another, and so on and so forth. So this is pretty neat when you can check the query performance. And well, if the query performance is bad, then you can just cache it or send it to a separate slave, so it won't affect your main environment. And finally, I would like to show you one thing, which is, because if we are talking about proxies, yes, so we're talking about some sort of high availability. So we have 2 ProxySQL deployed, but when one goes down, we would have to reconnect to the other one. And we can actually make it simpler when you install by installing keep alive d. So it works for HAProxy or for ProxySQL. So you can just pick the ProxySQL instances, type virtual IP, and then the virtual IP will be used to, you can use it to connect to the ProxySQL, and when the main ProxySQL master would go down, this virtual IP would be moved to the second standby ProxySQL instance. So then you are able basically to build a full HA stack using ClusterControl from the database tier to the proxy layer. And that was all I wanted to show you during the demo. So here are a couple of resources on the proxies in general that we want to show to share it with you. But finally, before we take some questions, there is a final poll, so I'm handing over to JJ.
Yes, thanks a lot, Christoph. Yeah, indeed. So we wanted to ask you, ask all of you now one final question before we move on to your questions and that we want to answer, of course, as well. But this is all around. So we want to ask you if you've tried the latest version of ClusterControl yet. So we've seen, the different features and capabilities and possibilities that Christoph described in the demo. And of course, it'd be great to know whether you've had a chance to check those out already, or whether maybe you're planning to. So it'd be great to get your feedback here. It's the latest version is only out since a week or two, so it's quite recent. So it may not be that it could well be that that you're not on the latest version yet, but hopefully you'll want to check it out after this webinar. So thanks very much for your participation in this final poll. And of course, you can ask us questions still in the question section of your control panel. If you'd like to do so, we'll answer them and take a few minutes now to answer your questions, of course, as well. I'm just going to close this now and share the results. Great. So thanks very much for your participation here. It's nice to see some of you have already upgraded to the latest version, and everyone else is looking into doing so, or will look into it. So that's good to know, and hopefully this webinar will have incentivized you to do so. So thanks very much for your answers here. Let's take a bit of time to answer some questions. And there's a first question here from David, and he's asking, if in the case where you want to replace HAProxy by ProxySQL, can you deploy ProxySQL on the same VM as you have HAProxy on, or do you have to create a new VM to do so with ClusterControl?
Yeah, so well, it depends. So by default, I mean, it all comes down to what ports are being used. By default, there should be no conflict. So basically, actually, in this particular demo that I gave, I had HAProxy and ProxySQL deployed on the same VM. But if you did some changes with ports, then you need to verify that the ProxySQL will be able to bind to 6033 and 6032 from what I remember. I mean,
great. Thanks, Christoph.
I mean,
yeah, sorry, go ahead.
of course, you can change it on the time during the deployment. So it is up to you how you will configure it. So yeah, that's about it.
Okay. Great. Thanks a lot, Christoph. I hope that answers the question. If not, David, feel free to, of course, contact us after the webinar as well. if you want more details. There's a question here from Lily, and that's the question is on the remote admin interface for ClusterControl and MaxScale 2.0. Is that still there? That's the question about the remote admin interface for ClusterControl MaxScale 2.0.
Mm-hmm. Okay, so the MaxScale, I mean, we are not really. It's not a ClusterControl MaxScale. It's just MaxScale from it's a separate company that created it. I don't know. I don't know any details. It was just said that it was due to security reasons. And to be honest, the branch like the MaxScale in general has a pretty relaxed security approach, because, for example, they required super user to connect to the database and then collect some data. So I would say, yeah, there are more problems than just remote admin interface. But I guess they had some problems. They had some reports, concerns from customers maybe, and that's why it was removed.
Okay, great. Thanks, Christoph. Thanks, Christoph. Yeah, and I see, Lily, that you had another question around some of the features, but maybe you want to email me those questions after the webinar, if you want to look into it a bit more. My email address is on the screen here, jj@cybernines.com. So feel free to email me there, and we can look into those questions in a bit more detail, of course, after the webinar, if you want to. So it'd be great to hear from you there, if you like. And I think so, because we're just after the hours, so I think that kind of concludes today's webinar. Thanks very much, everyone, for your participation. You can see here links to some of our resources on HAProxy, on ProxySQL, on MaxScale. Also, we have a number of blog series and tutorials that you can go and check out. And of course, we encourage you to install ClusterControl, and you have the link here for it, so that you can test, all of these different features and functionalities that Christoph described in the demo just earlier. But for now, thanks very much. Thanks, Christoph, for the presentation and the demonstration. Thanks, everyone, for your participation. Have a good rest of the day and the week, and we'll be in touch again with our next webinar, which will be on the 30th of May. And this will be on a topic around command line interfaces, actually. So this, if that's of interest to you, then of course we look forward to seeing you there. That'll be in three weeks from now. But for now, thanks very much, and have a good rest of the day. Take care. Bye-bye.